Hey everybody, today we are going to be starting a new series on this channel about logarithmic differentiation. So what this is whenever you have more complicated functions, specifically when you have a function to another function and you have to take the derivative of that. So it's not something like e to the x. We know how to take that derivative. It's something more like x to the x, or x to the sine x. Stuff like that there are two functions of x, and we have to take the derivative of them. So this causes a lot of problems, because we don't actually have rules for that, so we have to be creative with how we solve it. And we solve it by using logarithms. And yeah, so I'm going to, in this series I'm going to be doing a lot of videos. I want to do a lot of derivatives on tetrations, and I'm going to go more into that later. But this is kind of an introductory video with the process, okay? So in the next video I'll have the derivative of x to the x and x to the x to the x, and in future videos I'll have more tetrations like that, and other random things like sine x to the cos x, or whatever is possible, you know? So this is the introduction. So the derivative of f to the g, okay? I'm going to simplify this by just calling this d dx of f to the g, okay? This, because we're going to keep writing f's and g's and f primes and g primes, and it's just, whenever we have the x there, it just makes it so long and just hard to read. So I'm going to be simplifying it using that, okay? So your first step, so I'm going to put a step 1 right here. So your first step is to set your input to set it to y. Y is equal to f to the g. Okay, don't worry about the d dx for now. We'll go into that a little later, okay? First step, okay? So now, what we're going to do is we're going to take the natural log of both sides. So I'm going to apply a natural log, I'm going to apply a natural log here and a natural log here, okay? And so step 2 is your natural log. So we have ln y is equal to ln of f to the g, okay? The point of this is because we can use logarithm rules to move this g in front of the natural log. That's just how they work. So we can simplify this by putting ln y is equal to g times ln f, okay? Now that we have it in this form, we don't have a function in the exponent anymore. This is implicit differentiation. This is the product rule. This here is the chain rule, because natural log of a function, that's two functions, it's the chain rule. And so it is complicated because we have to use 3 different things, but it's possible now. This on itself is not possible. We have to manipulate things sometimes to be able to take their derivative. So, basically all we do is we just take the derivative of both sides. So I'm going to put, our third step, we're going to take the derivative of both sides. Okay, so derivative of the natural log is just 1 over y with our dy dx, or y prime, whichever you choose. That's just implicit differentiation. And then, here, so we take g, and we multiply it by the derivative of this, which is not just 1 over f. So we put 1 over f, but again, because it's the chain rule, we have to multiply by the derivative of our inside, which is just f prime. Okay? We don't know what our functions are, so we're just going to leave them as g and f. Okay? And so then we're going to add the ln f, and then we're going to multiply by the derivative of g. Okay, so now our fourth step is to isolate our dy dx. So we just take dy dx And the way we isolate is by multiplying by y prime. By y. So we have y, 1 over y, if we multiply that by y, then we get dy dx on itself, and so we have to multiply this side by y, okay? So we take y, and I'm going to do some simplifications here. So we can do, we see gf prime on the top, divided by f, then we add g prime ln f, okay? And y, we said was f to the g, so we can actually just replace this with f to the g, and that's it. That is our derivative. It's not fancy, it's not beautiful, it's kind of messy, but this is actually really cool because it allows us to take more interesting derivatives. And so in the next video, I'll introduce you to the first actual example. But before we do that, I want to introduce you to another idea. Titration. What this is repeated exponentiation. So we know that multiplication is repeated addition. Exponentiation is repeated multiplication. Titration is repeated exponentiation. So let's say we have x to the x to the x to the x, okay? This is pretty wild. We're taking the exponent several times. Well, we can actually simplify this. This is the fourth titration of x. So we have 4 x's, so that's the fourth titration of x. So we put the exponent in the front. So this is titration. We put the exponent to the front, and that denotes this. So basically when we have x to the x, that is the second titration of x. Oops, not so big. Second titration of x. And just x by itself is the first titration of x, which we can just write as x. So yeah, that's a little ugly up there. So yeah, I mean that's titration, and the point of me showcasing this is because I'm going to be doing a lot of these. I'll take the derivative of this eventually. I'm going to take this, the third titration, the fourth titration. I'm going to do as much as I can. Unfortunately, I don't know of a lot of resources where I can verify that my answers are correct, especially with the higher order titrations, because there's just the answers are so long sometimes, especially the more you go. So I can't guarantee that my answers are going to be 100% correct, but I'll double check as much as I can, and I'll make sure I do everything right, and I can give you a good estimate that it will probably be right. But as I said, I can't guarantee that. But anyway, yeah, titration, this is one big part of logarithmic differentiation. We also have other things, like as I mentioned, like, I don't know, the natural log of x to the power of sine of x. Stuff like that. We're going to be taking a lot of logarithmic differentiation, or logarithmic derivatives. So yeah, welcome to the new series, and in the next episode I'll be doing x to the x and x to the x to the x, the second and third titrations of x. So yeah, thanks for watching.